I don't believe it. I don't believe it. It's finally here. You see so few of these in Australia. Oh yes. Glory be to thee, Leo Fender, for you have provided a Tweed Princeton. Hi, this is Chris from Sydney, Australia. If you want to join me as we make this amp safe and sound great in 2022, go grab yourself a coffee. Get one for me too. I'm distracted at the moment. These are so rare in Australia. It is going to be such a treat to get stuck into this amp and just bring it back and make it safe, first and foremost, and make it sound fantastic again. Let's have a closer look at it. Original badge is still intact. Oxblood grill cloth, I think we'd call that. Tweed is definitely road worn. It's got some real character. So here's the inside of the chassis and 2-pin American transformer. Not going to change the power transformer. It's part of its history, so it'll stay as is. We'll be using a 240 to 110 step-down transformer here. But we need to get a 3-pin on there because there's currently no earthing for the chassis. I think we need to call out the white elephant in the room. This Celestion 815 speaker. It is really just a wrong choice for this. We have ordered a new speaker and it'll be arriving any day now. So you have just got to hang on, and when you see it, you're going to go, good choice, Chris. It is the best speaker for this amp. I've also put one of these speakers in my Champ, and it sounds great. So that's why, with confidence, I suggested to the owner that we use that speaker. I'll tell you what it is soon. Don't be so impatient. That's going. So we know this is a 5F2A. The easiest thing to see is it's got this cathode bypass cap there, which wasn't in the 5F2, was in the A. So this is the A circuit, and I can see these 3 filter caps have been changed, and this one, 22 microfarad, is not the right value. Where's my 5F2A drawing? What we've got in that first stage of filtering is 2 16s in parallel. So I need to get a 30 microfarad filter cap in there, reservoir cap, do that job, because they can be a little bit noisy. Insufficient filtering is one, but a 5Y3 doesn't want to take too much filtering, nor do I want to deviate too much from the original design. I'm going to keep as much original componentry as I can. I'm going to check each one of these resistors. Hopefully they're within 10-15% of their spec value. Likewise, I'll check all of these capacitors, actually even the newer ones, for their capacitance value and ESR values. I hope these Astrons are still okay. I'd like to retain those. There's the domino cap up here, another cap here, another Astron. Mustard colour one there. I'm going to test them all, make sure they're okay. Likewise, I'll be checking the 6V6 and the 12AX7. And it looks like we've got that 5Y3 is a nice American RCA one. This one is a Sylvania, nice. And under here is a Sylvania 12AX7. So I'll test all these. Hopefully they're still okay, because that'd be a nice treat. So the other reason that they can be a bit noisy is the heater wiring. Normally, if you look in a larger amp than this, you'll see they're usually green. Green wires are sort of tight, twisted pair, and that twisting helps to minimize the noise. In these early Tweeds, they didn't do that. They had one end of the heater, well, it might be easy to see it here, they'd have one end of the heater grounded and the other end would just go off to the two tubes. And that can be a little bit noisy, so a bit of filtering, a bit of better filtering there might help. The earlier ones had a choke in here. This one with the 5F2A, it's been replaced with this dropping resistor between the plate going through the power output transformer, and there's now a 10K dropping resistor to supply the screen. That might be adequate. I don't know, some people like to put in a screen grid resistor there as well. Yeah, I don't know about that. I mean, it's probably good to have it in there, but I don't want to deviate too much from the design, so I probably won't put in a, I'd use a 470, some people use a 1K. Our first step is to make it safe. We can see here that it has a depth cap going from the fuse to the chassis. So we're going to have to, I'll probably just clip it and tuck it back in there so it stays in there as part of the amp's history. But we certainly don't need to have a depth cap in there. When we say depth cap, it's this cap here. And because in America, you used to be able to just flip the cord around one direction or the other. So there was really no active or neutral. And you can see here they would switch one line and fuse the other. Man, that's just not on today. So I'm going to rewire it. So we're going to go active to the fuse first, to the switch, and then the neutral is going to go straight back to the transformer, power transformer. It has to be said, Americans are odd. They drive on the wrong side of the road. They can't say all in solder, even though there's clearly an L in the spelling of solder. And most importantly of all, they can't get their mains wiring right. Yes, Americans are odd. So let me just check in with my young apprentice. So Harley, when you're looking at a PowerPoint in Australia, is the active on the left or the right? It's always on the left, Dad. Okay, so here's the dilemma. I've got here a USA lead, and just to prove the point that it's working, green to earth, and it's working. Now in Australia, the left, as you're facing the PowerPoint, is active. So if I put that there and then contact the black wire, which is active for some reason in America, we have no contact. It is the right-hand pin. That is active. Why is this significant? Well, it's significant because is the step-down transformer that you buy in Australia, is it going to be configured so that the plug that goes into the Australian outlet has got the mains on the left-hand side of the earth? Or is it going to be, and it's going to need to have the active on the right-hand side on the USA side. So the active is going to come in here, the new active lead is going to come in there. We want it furthest away from where you're likely to be contacting that fuse. So there we're going to put a link from the fuse to the switch, and then from the switch to the transformer. So that lead can stay as is. And I just need to put a little link in there. Got some black cloth covered wire, which will just fit in nicely there. down there nice and neatly, leaving a bit of slack there should anyone need a bit of extra wire. That's going to go there. Okay. While you were out having a coffee, didn't ask me, but while you were out, I put in the new cloth-covered power wiring. I wired it the USA way, but left the brown wire being active. So I've intentionally connected the brown wire to the right-hand pin, not the left-hand pin. So I'm just hoping that whoever has the step-down transformer has wired the input the Australian way and the output the American way, and that'll all be fine. If not, I'm just going to offer the owner, the new owner who buys this amp, that I will exchange it over for no additional cost. We just have to make a decision somewhere. Okay, so I'm going to leave the death cap in there, and I've covered it with some heat shrink. Okay, question, why did I cover it with heat shrink? Answer, yes, so it doesn't accidentally touch anything like the fuse, which it's quite close to. Even more importantly, I've left it there so a future tech would know that I intentionally cut that off and it didn't merely break off, and he would have reconnected it. So it's my secret sign language to a future repairer. I might just tape that down until that silicon sets. Okay, so I'm now going to solder this brown wire to the bottom end of the fuse. Like so. You can live down there. Henceforth, I'll solder the earth to the chassis here. And I will also directly connect the neutral to the transformer. In the Tweed era, the Princeton models were more closely related to the Champ. Main difference being in the earlier Champs there was no tone control. Here we've got a tone control. But still single-ended. Is our B plus coming through the output transformer into a single 6v6 through a cathode-biased method of biasing the tube. From the brownface era on, the Princeton was more closely related to the Deluxe insofar as it was a push-pull amplifier, two 6v6s, and whereas the Champ still stayed as single-ended. The Princeton was different to the Deluxe. The Deluxe had a long tail pair output stage, and the Princeton had a cathode phase inverter, which I quite like. We have here two 16 microfarad caps in parallel, giving us 32 microfarad. Whoever worked on this before is quite good capacitors, but 22 microfarad, which an amp which is sort of like prone to have a lot of noise because of the way the heater was wired. I think we'll bump this up to the design spec of 30 microfarad, and this I ordered. And I've now got the 30 microfarad F&T cap, which we'll put in here. Now I'm not sure if you can see this or not, but the leg of this capacitor is going to the shield, and it would be awkward for me to get my big 120 watter in there without damaging the capacitor there. So what I'm going to do is I'm just going to cut this off here and then just solder it to that eyelet there. Just want to straighten these legs out a bit. Whoever packed them in a very compact way, which meant bending the legs over. All right, we're going to take a look at some of the other components in here now. And, well, you can watch in on the meters that we're using. So I want to set electrolytic capacitor. I want to take the test frequency down from 1 kilohertz down to 100 hertz. And we can see here that there is no 8 microfarads. So we'll go somewhere between 8 and 10 ohms we'll be looking at for the equivalent series resistance. Let's check this one here. Reading nicely at 8 microfarads, and that is definitely below 8 ohms, 9 ohms. And here, even better, so 8 microfarads again, and an ESR of 4.9 ohms. So both of those filter caps are okay. Let's check out these 2 cathode bypass capacitors. Now this is not mains frequency, rectified mains frequency of 100. So I'm setting this to 800 hertz there, which is pretty much a pretty high A. We should hope to see around about 2. We're getting 3 there. That's 50% too high, borderline. That's marginally worse. The red, displayed value of capacitance is also a bit out. Look, I'm inclined to leave them only because this is such an important amp historically. I'm not going to tamper with it unless it's really bad. So I'm going to leave those 2 in. All right, now these are coupling caps, 0.02. Now, 23 nanofarad is 1, 2, 3, so that's 0.023 microfarad. That's pretty much spot on. The ESR isn't as relevant for a coupling cap as it is for a filter cap. Leakage is more important than this, but we can't measure leakage with this. And why is leakage important? I'll just quickly mention why. If this capacitor here, for example, is leaking DC, and the DC there, as you can see, is going to be pretty high, 300 odd volts, or high 200s. If any of that DC leaks through to this 6V6 here, it'll red plate that. So we don't want leakage. These are normally pretty stable, these domino ones. And that is going between the volume and tone. That's this one here. And that should be 0.0005. So this is how we're going to do a conversion from pico to microfarads. 658 picofarads. And we've got 0.0000000. That'll do. And that's there. So let's convert it to nanofarads. So we're going to go 1, 2, 3. And let's go to microfarads. 1, 2, 3. So this is equivalent to 0.00066 microfarad. It's a little bit out, but it's probably even more than 20% out. But I'm just very conservative when it comes to replacing anything where your signal passes through. I just like to have the label visible from the back. so the customer can see what readings I found. Now, before we apply power, let's just have a little bit of a look of the difference between the 5F2 and the 5F2A. And one of the differences that we'll see here is in the power supply. You'll see the 5F2 has a choke, and the 5F2 has dropped that choke. It's put a dropping resistor of 10K between the B+, which feeds the plate, and then the supply to the screen. So why was that choke dropped? Well, probably cost. You'll see the choke can get away with smaller filter capacitors because the choke itself, which is an inductor, just a coil of wire around a bar of some ferrous material, whereas a capacitor resists change in voltage, an inductor resists change in current. So in both cases, they work together to minimise ripple. So here, to compensate for the loss of the choke, we've now got increased capacitance, and I've now brought that capacitance back up to this design spec instead of a lower 22 because we've lost the filtering component of that. So the other thing here is you'll see that there isn't a screen dropping resistor here anywhere. So there's a concern if something goes wrong with that tube that it's going to start suddenly dumping a lot of current between the plate and the cathode. That current may have an adverse effect on the output transformer or even the power transformer. So in a way, the screen dropping resistor, can act a bit like a protection device. If suddenly a lot of screen current passes through, it might take this out, and if that goes out and that voltage drops to zero, that tube will effectively turn off or just have a lot less current going through it. So it's a bit of a protection method as well. Sometimes very often you'll see another screen grid resistor here, which could be 100 ohm, 470 ohm, 1K ohm. They're common values that you will see for a screen grid resistor. In this case, Leo's put his faith in this to do that. Sometimes I'd be tempted to put in an additional resistor, but I'm not going to do it here because of originality. So I just wanted to bring that to your attention. Okay, now I'm going to slowly power up the voltage here. Now we've got a very nice RCA 5Y3 rectifier here. So we're going to plug this in, and that's there. And I'm going to start increasing this voltage. I also want to do a bit of a slow startup because we've changed that filter cap, and it's not good to suddenly scream in its ear, "Wake up!" It's good to just sort of gently sing lullabies to it. Let's just have a look at our voltages on the 6V6 socket. The 6V6 is currently not installed. So pin 3 is our plate, and it's got 422 volts on it. Pin 4 is our screen, 421. All right, I have lifted the leg on this capacitor. So I'm going to show you a couple of ways of testing that. If this was not leaking at all, then I'd expect that to be 0 volts. It's currently showing 105 volts. The only reference to earth is through the meter on the allegedly low voltage side of that capacitor. But this is a very high input impedance, so I want to load it down a little bit more. So I have made myself a little leakage tester, which has got a little diode, a little resistive network here, and an LED. And I don't know if you're going to be able to see this or not, but if I attach the LED to that and this light comes on, it means we've got leakage to ground. Yeah, I can see that. I don't know if you can see that. So that capacitor is definitely leaking. It's going to have to go. While I'm here, I might as well do the same test on the other one. So I'll just discharge my main filter caps. Here's fairly substantial capacitance here in this reservoir capacitor, which is that one there, is equivalent to both of those. How is this getting discharged to ground? Man, slowly is all you can say, very slowly. Let me just measure that voltage now. It's been off for a little while. 390 volts on it. And let's be honest, that's not rocketing downwards, is it? Very dangerous. Power off, and yet it's still got 380 volts on it. So what can we do? We can just leave it and be aware of it. I'm very much inclined to put in a little resistor across that capacitor, this one here, of, I think Fender used like 220k. So I think I might put in a 220k resistor there to just help that capacitor discharge a little bit more, or even bigger, I don't care. 330k doesn't worry me. I would like to tuck it underneath there so it's out of sight for originality's sake. But capacitors and heat generated by resistors are generally not good bedfellows. So I might opt for a larger resistor just so it's going to, you know, discharge faster than that. And what are we up to now? Still got 360 volts on it. It's just not good. So you have to always discharge it and not trust an amp to discharge itself. There's my little patented discharge device. I'm not sure if you saw that little spark. Maybe my fat hand was in the way, but pretty sizable spark there. I've got a 100 ohm resistor in there, 10 watt by the looks of it. And if we measure that voltage now, I bet you it'll already be down to zero. Yep. So I'm just curious to see if that 470k is going to effectively drain this off. Look at that. Much happier about that. It's nice and slow, not putting any load on anything. I'm glad I did it. And I've managed to find a carbon comp resistor, so it looks totally original. Let's just do an accurate measure on the cathode resistor. It says it's supposed to be 470. Let's see how close it is, and we'll just note it down. These carbon comp resistors nearly always drift high. So that's, we're going to call that 4922. Voltages around the 6V6. Here's our plate. $340, we like that. Here's our screen, 311. And here's our grid, 0, perfect. The voltage across the cathode is 19.0. That means the current going through the cathode is, well, you remember this equation, I'll just show you just in case you've forgotten. V equals IR. So if we want to find out the current, it's V on R equals I. So 19 divided by 492.2 is 38.6 milliamps. Now, what is the dissipation of the 6v6? So we need to measure the voltage now between the plate and the cathode, not just the plate, because we're going to be out by 19 volts. Now, do you remember your equation for power? Power equals VI. So it's going to be power equals voltage, 320.5 times the current, 0.0386. Because that's milliamps, that's amps, of course. 320.5 times 0.0386, which equals 12.37 watts. X has got a dissipation of 12 watts, maximum dissipation, and this is in class A, so we want to be running it at pretty close to 100%, 95 to 100%. It's 103%. I can take it up, increase that resistor slightly, which will increase then the voltage drop across there, which will make this more, that'll make that cathode relatively more negative than this, so it'll shut it down a little bit. That is near enough to damn it. I'm going to leave that one as is. I just want to hear it now and see if we've got any noises that are undesirable. I don't have a 4 ohm speaker in the workshop. I've got an 8 ohm speaker. This runs the same impedance as a champ, which is a 4 ohm speaker. But generally you can go up and down, you know, one step. It's a volume on 3. Guitar volume down a bit. Guitar volume up full. Oh, that's the sound we all die for. Tweed amp just on the edge of breakup. Totally touch sensitive. Oh, all right, can't wait to do the sound check with its new speaker. Oh, I haven't told you about that yet. I will soon. Okay, what's left to do? Right now, I'm going to clean all of these tube sockets. And you don't need to see that because it's boring as batshit. I'll clean out the speaker socket. I'm going to clean the contacts here. Let's just check them. When I open up that earth, we should get somewhere between a mild ha to a burn. Ah, that's a mild ha. Ah, that's a bit louder, as we'd expect on that one. All right, I'll clean those up. The earthing leaf there is obviously working, but I might as well give it a clean, seeing I'm here, and just coat it with a little bit of deoxygen. I think I may have been a bit harsh with this Celestion speaker. It's actually incredibly good value for money. It sounds quite reasonable, very acceptable sound. However, My brief from the owner of Sunburst Music, who owns this amp currently, is to make this amp as good as possible. We don't spare expense. We keep as much original as we possibly can. And I have taken this brief very seriously. And so this speaker has to go. So, what, in my opinion, is the best 8-inch speaker that would fit in this? Well, for a start, it has to be an AlNiCo speaker. This is clearly ceramic. So I'll show you what I ordered. Are we ready? Straight from the USA. A Weber speaker. 8A125 model, that means 8-inch, AlNiCo 1.25-inch speaker cone diameter, 4 ohms, which is what we need for this series, the Champ and the Princeton, 20 watts, heaps, we'll never get this thing to break up, and obviously fresh off the press. I spoke to CJ Sutton at Weber, and he agreed that this would be the best speaker for this amp, and we ordered it without the bell cover because it's a pretty tight fit. I've got a 8A125 in my Champ, and I tried it in the Princeton first before ordering anything, and the bell cover just cleared the tubes by so little. So CJ started the manufacturing process for me without the bell cover, and I think that looks probably more original anyway. It's a beautiful speaker. I know it because I own one too. Let's just remove the old speaker. I said this is a perfectly good speaker, and if someone's working on a Champ project or something like that, this would make a fine speaker. Now, while we have access, let's tighten this up. Yep, as we thought, these have just rattled loose over the decades. Yep, loosey-goose. It'd be just so annoying to go to all of this effort and then have the speaker rattling, or the speaker baffle rattling against the cabinet. Good. Put this here, and we're going to very carefully, because it wouldn't be the first speaker I've seen with a hole in the cone, especially when you have this bolt pointing upwards type of scenario. Where one of those bolts has gone through the cone. Yes, you can repair it. Yes, the sound would be unchanged, but hey, it costs quite a bit of money to get a Weber speaker into Australia, and you want to treat it with the utmost of care. I was very privileged to have spoken to Ted Weber. Oh gosh, when was that? I'm going to guess and say it was about 30 years ago. And I still have the very first speaker he made for me. It's currently in my Marshall 18 watter, hand wide 18 watter. Very close call between the British greenback Celestion and the Weber, and I A-B'd them several times, and once again Ted came out on top. Oops, wrong one. And then when I got my 410-63 brown-faced concert, I rang up Ted and I said, "Oh, Ted, it's got these Jensen mod speakers. What have we got that sounds better than that?" And he said, "Chris, any of my speakers would sound better than that." I've got to say, what a treat it has been to work on this little bit of musical history. The sound is awesome, as you will soon hear. But before I go into that, if you got anything out of this video, would you mind giving it a like and subscribe if you haven't already? Also, I should say that I've been paid by Weber Speakers to promote them. I just love their product. I paid normal price for the speaker and shipping to Australia. Likewise, yes, I'm being paid by Sunburst Music to do the repair, but nothing for anything I say of a promotional nature. That's just purely my love for that company. Okay, let's have a listen to how this thing transitions so seamlessly between clean and spanky and chewy and gritty and all those other nice meaningful words. Oh yeah, that's what I'm talking about. This is beautiful. But I'm going to see you at the next repair. Till then, take care. See ya.